Hello to everybody out there that's interested in basement apartments. My name is Paul Anderson. I've owned basement apartments for 20 years now, and I've built 6 of them myself. And I want to tell you a little bit about a project that I completed about a year ago. This project, it had no plumbing in the basement. So as you can see from this picture, we took out the floor. We had to put in the plumbing. Here's a couple of pictures of the kitchen and the bathroom, just simple kitchen and bathroom. We designed the project ourselves. I did have consult with a house designer with lots of experience. Those guys do mostly custom homes, and talked through the design with him just to make sure it didn't make any mistakes. So anyway, we had to take out the floor and then set plumbing in, and that's what we're going to talk about today. All about how to set that rough plumbing so you don't make mistakes. Then we also had to put a pump in, and here's a couple of pictures of the pump. One of them shows a diagram of the inner workings of the pump. It's basically just a pump with a float, so as the sewage actually drains right onto the pump, and then as it gets to a certain level, the float makes it pump down, and so it cycles on and off. But I didn't know that the sewage jumped right on the pump, but I guess that's how all these pumps work. And then what we're not going to get into too much in this video, but I did want to mention setting the tub is really the most difficult part of this process, because you have to get the framing just right, and then the drain just right, and then you have to set the tub in mortar usually. And it's just really, to me, that's the hardest part. But the plumbing obviously has to be done just right, because you're going to put it under concrete and then put it under flooring, and you're never going to be able to fix it if you didn't do it right. So anyway, this video is all about how to do that process right, and I hope you enjoy it. This is Chris. He's my brother-in-law. So Chris is a master plumber. He has about a little over 25 years experience in plumbing. So he's supervisor now, but he's got lots of experience. So we're going to tell you all about how to do a rough-in system today. We're going to introduce this as a model of the whole apartment plumbing, and we're going to tell you all the elements. This would be the kitchen sink. It has a Studor Vent in it. We'll go over that. This represents the washer dryer. In this apartment, we have the bathroom, and then the washer dryer is actually in the bathroom. We'll talk about the plumbing for that. There's some special plumbing for a washer dryer. Then this is the toilet. We have toilet paper for the toilet, but that represent the shower. And then this is the bathroom sink, and it has a vent also.
So this is a typical design, but it's not to scale. But this gives you an idea of how it's installed, right? So this would be your existing sewer main in the basement of the house. And what you would do is you would cut into that line. This is the new line feeding your bathroom, and just imagine this is inside the framed bathroom, right? So this right here is your, okay, so this line here can continue to go to your kitchen somewhere else. This goes into your bathroom, then your first branch is your laundry, second branch is your tub or shower, next branch is technically your sink vent, and then the last branch is your toilet. Now this could be spread out more, but there's requirements to make this vent properly. Venting air is very important with the plumbing system, okay? Very important. What that means, you have to have a source of air feeding all the fixtures. So this right here is what you call a horizontal wet vent, okay? So meaning the source of air comes from right here. This is your bathroom sink. The sink water and air mixed together come down this pipe, and this section right here is your horizontal wet vent. So this toilet is being vented from this sink. This tub or shower is being vented from this sink. This group right here is what you call a horizontal wet vent. That ends when you get to your laundry, which is this right here. This laundry would have to have its own separate vent going up to the roof like this one does. It'd have a fitting similar to this on it. Have a vent to go up to the roof. And this vent here would also go to the roof. Now when you come over to your kitchen, the kitchen has what we call a mechanical vent or a Studor vent, okay? This device right here has a diaphragm in it that opens when there's negative pressure in this system. So when you turn your sink on, fill it full of water, that weight of that water pulls down and draws a vacuum, which opens this diaphragm up, which relieves the pressure. What you're trying to do is you're trying to balance the pressure inside the system to be equal with the pressure in the atmosphere in the outside of the system.
So you don't want to. You want the water to flow by gravity.
Yeah.
You don't want it to be sucked down by
These things
siphon.
right here are called P-traps. What they do is they prevent sewer gas from the plumbing system leaking into the house. And these always have water, like this one right here, this one right here. They always have water, and that's causing a liquid barrier to prevent that sewer gas from coming out. If there are no vents, when this kitchen sink would run, it would cause a vacuum, which would suck these dry. You'd have sewer gas come in your house, which is unhealthy.
Also, with no vents, the water doesn't flow as well, right?
It doesn't flow as well. It has a tendency to cause a siphon. If it can't cause a siphon, it'll get stuck. It has a tendency to get stuck where it is. So it'll eventually get there. Sometimes it will, sometimes it won't, but it won't work right. You'll hear bubbling, gurgling. It's just not the right way to do it. It won't. Eventually, you're gonna have problems.
Okay.
It might not happen overnight, but it will happen.
So let's get into the.
Okay, real quick before we get into that, I want to get over the Studor vents and the air vents. Now, there's lots of codes. There's lots of jurisdictions. I'm licensed in 8 states, and every state is different. But for the sake of splitting hairs, let's just say that these air admittance valves versus an open vent, let's say you have to have a balance. You never want to have all of these. You don't want to have one here, here, and here. You want to have a balance. Let's say, so every Studor vent you have, it's good to have an open vent. Makes sense? So when you're designing your system, you're going to look for the framing where it's easy to get a drive-in out to the exterior, and the places it's more complicated, like an island kitchen or something like that, you can use one of these. So look in advance and figure out where it makes the most sense and where it's most cost-effective to utilize these devices right here. So that's what you want to do.
So this kitchen, the wall was still finished, and so we would have had to tear the wall all apart to get a vent out to the outside. Mm-hmm. And vents that go to the outside are better vents.
They're better vents, but they're also more work to install.
Okay.
Yeah.
So where you cannot get a vent in,
Studor vents are the solution.
check your local code.
Yeah, check your local
They're
code.
not allowed everywhere.
Yep. Depending on the jurisdiction, depending on the state, some places allow these to be used everywhere. Some don't allow them to be used at all. I have a personal preference of balancing it about 50-50.
Okay. And you wouldn't want to use a Studor vent in a washer dryer?
You could, but you want to make sure you had a dry vent somewhere near it as well, which would be your tub in that, or your sink and bathroom group in that situation. You could use it on anything you want. You could use it on a toilet. You could use it on a laundry. You could use it on a kitchen, but you don't want to use it on everything.
Okay, so while we're talking about venting, so the washer dryer comes in here after the part that's vented.
Yeah, this is what we call a horizontal wet vent. This section. This is a bathroom group right here.
Okay, so after the bathroom group, which is all vented through the bathroom sink, then the washer dryer, we put it in down here. Mm-hmm. Now, why wouldn't we put the washer dryer in over here, or could we put it in over here?
Because this has the pump from the washers pump out too much water, and it would cause an overload of this vent right here, which is the first problem. The second problem is the code specifically says that only a bathroom fixture could be within a horizontal wet vent bathroom group, which is this right here. So there's 2 reasons you can't do that.
So even though the washer dryer is in the bathroom, it's not really part of the bathroom.
Depending on how it's installed would dictate how that is done. It could be located in there, but the plumbing, the way the plumbing is designed, will separate it. So that's still possible to put it in the bathroom.
Yeah, but it's really it's down. It comes in downstream of where all the bathroom stuff is.
Exactly. Yep. And there's usually room in the bathroom to cut that in.
So one of the first principles of putting the plumbing system together is the sweep of the pipes, where you transition. You can see we have a 45-degree transition here. We have a 90-degree here. And you want to be really careful that you have wider sweep pipes. Wider sweep pipes are always better. And this is this one that's got a longer sweep. These are all 3 90s. This one's kind of a standard 90. And then this one is a really short 90. It's called like a vent 90. Now, Chris, these are legal to put underground, the standard ones, right?
In certain situations, yes.
Okay.
So this right here is a vent 90, and it's used on something above this point only, which is carrying air.
So what would happen if you put a vent underground? It would still flow.
Well,
if you're lucky, right?
It would flow to a point, and it would eventually back up. The fitting's too tight of a turn, you'd have problems with it. You do not want to put this on the ground. You'd eventually have reoccurring issues, and you want to avoid that. So this is, like you said, this is called a Vent 90. This is a medium sweep, and this is a long sweep. This medium sweep right here is just designed to go from horizontal applications to vertical applications, which is typically not under the slab. Now, if you do have a multi-story house,
going up towards the toilet though would be under the slab. So that's where a place you could use it.
Could be used, but like the situation here, you wouldn't want to see this be used.
Horizontal. Running horizontal, you don't even want to use the standard 90.
Yes. This is what we call a long sweep 90. This is what's designed to be used horizontal to horizontal or horizontal to vertical. So you could either use this to make a turn somewhere like this, or you could use it to make a turn going up out of a slab into a wall like this.
Okay.
So and there's also another way to do it, which is how you've done over here, which is using 245s to make a 90. And the reason you do something like this is if you have a...
We have the footer
the
house
something
footer here
that you don't want to remove, and that's a way to get around. And you can hide this kind of stuff in a cabinet toe kick, something like that, or you can bring it up in the cabinet, like under your kitchen sink here. So this could be exposed. It wouldn't hurt anything.
This is the bathroom. So this is
you can do the same thing in a bathroom.
Now I want to ask you, we have mostly 45s in here. Now 45s are good, right? And why are they good? They act like this, right?
Yeah, they're better than a 90 because they cut the offset. So this is called this is called a combo. So this is essentially a Y with a 45 built into it, which is a really long sweep 90. Right here, this is a Y with a 45. So this is what we call a combo as well. So you're taking a Y, which is a 45, with another 45 to make a 90 degree, but it's doing it in a very gentle way.
Okay, and when we design our system, 45s are good to use because we can have the offset, and so we go horizontal as far as we need to go this way, and then we go into where the toilet is. So we have the toilet was close to where we came off, so we just have a small piece of pipe here. But really 45s are pretty handy to use because they allow you to travel, have a run and a run this way. So then
change direction, but without causing issues for sure.
Yeah, and they're really good for, so they make 22 degree angles, 45 and 90.
And also 60 degrees.
They also make 60, but those really aren't supposed to be used under horizontally because they're kind of too much angle. So those are the three elements that you have to work with to get where you need to go under your slab. So to work the geometry.
Yeah, just to make a note, there are several ways to do this. What we're trying to do here is make it the simplest, cheapest, cleanest way to do it properly. Like Paul said, there are different fittings that can be incorporated. There's different venting styles that can be incorporated. But this is the way that we've found is the cheapest way to effectively get this done. So there's not necessarily just this way. There are other ways. We're trying to accomplish it the cheapest way as possible, just so you're aware.
Okay, one little detail is when you go up, this is called a closet elbow, right? When we go up here from our 3-inch pipe up into the toilet flange, a closet elbow is a good thing to use. It's the only place in a house where you're actually going to reduce from 4-inch to 3-inch.
That's correct.
You never really reduce. You notice when you flush something down the toilet, it's a smaller hole, and then it goes into a larger hole. The pipe's larger than the toilet. And the same thing in a sink. You're going to go from smaller always to larger, so always to larger. But they allow this so that you can put a bigger toilet flange in that will flush better.
Yeah, they allow this so that you can have a lot of options when you're installing a flange. Depending on if this is installed in concrete, wood, the grade depth, there's different types of flanges. You've got all plastic, you've got plastic with metal rings, you've got flanges that go inside the fitting. You can also glue a piece of pipe in here like this. And then when you pour your concrete around it, you can actually cut that pipe off flush and then make a fitting that goes inside that pipe.
Yeah. We actually, when we poured it, we cut the pipe off and then we had to chip the concrete out. So the flange went over our pipe. Yeah. So there's a lot of different ways you can do it.
There's another version of that where you could avoid chipping, which is why you have this size right here.
Yeah. So I think in ours, we actually just used a 3-inch we didn't use the closet flange, which is 4-inch where the
4x3.
flange goes on. We used a 3x3, and so that's why we had to do the chipping, so we could get the maximum.
Which is still fine.
amount of
It's
flow.
just one way to do it. There's several ways to do it.
So when I went to the hardware store, there's literally like 5 or 6 different types of flanges. I only have 2 here. Could you just explain what some of the different flanges are used for?
So they're all basically the same, sort of same purpose. This one here is all plastic, which tends to make it cheaper. It's also thicker here, which you could use to raise the flange up if you have like a tile floor you're trying to match. This metal one here is a little bit stronger, a little bit more expensive. It's also a little bit thinner, so if you have like a linoleum floor or something like that, this will help drop the toilet down. So that, because you don't want toilets to rock when you set them, you want them to be able to sit and support their own weight on the floor. So if you have a flange that's thick like this on a linoleum floor, there's a chance the toilet might rest on this and not on the floor, and it will rock. What will happen is it'll actually eventually break these flange bolts, and then the toilet will start leaking. So you want to avoid that. So you need to think about that in advance when you're deciding what type of flange you want to use.
So with our toilet, we were coming up on concrete, and we came up with a 3-inch pipe, but say we could have used this. What would be the ideal flange for coming up on a concrete floor?
So if it was me...
And by the way, our finished floor was just LVP over the concrete, so very thin over that.
Okay, so if that was me, I would have used one of these with a 4-inch riser, piece of 4-inch pipe. And when the concrete was finished and the flooring was done, I would take and cut that pipe off flush with the floor, and I would have used a fitting that went inside. See, this fitting right here goes inside. This is inside the fitting hub type of a flange. I would have used one that actually glued inside the pipe, and it would have glued inside the pipe. It would sit flush on the floor, and this would be sitting right on the concrete.
So you'd have a 3-inch or 4-inch pipe, so you got plenty of. It's better to have a bigger hole.
Yep.
Plenty of big hole, and so it's kind of the best of all worlds that way.
Yep. And then you have the thinner metal, so you have the LVL's thinner flooring. So this thinner flange will help keep that toilet down lower, so that it's not rocking.
Okay. And then they have different things for, on a second story or second floor, you're going to be working inside the floor joists, and so there's all kind of different configurations.
Lots of different
you can get
scenarios,
into.
yeah.
Okay.
You don't have to use a 4-inch riser. You can use a 3x3. You can use one of those fittings, these 3-inch 90s right here. You could use a 3-inch 90 going up with a flange. That still works. Obviously, different suite, but that's still perfectly acceptable depending on the situation that you're going to find yourself in.
So now I'm going to tell you a little bit about wax rings. This is just a basic standard wax ring. I know they make taller ones, and they also make synthetic wax rings. Mm-hmm. So tell us about what your favorite is to use, and it probably depends on the situation.
I like conventional wax. I think they're the best way to go. The synthetic ones, I've had issues with those leaking, with them not sealing properly. I've had the best luck with just a conventional wax ring. And what they do is they'll just sit, this wax ring will sit on the rim of the flange.
Now they also make the reinforced ones with a
horn.
Plastic throat or
yeah,
horn.
It's called a horn, yeah.
So are those better, or is this?
I like those, but you got to be careful with those, because if you have a toilet that's close to the floor and you don't have a lot of room to work with, you want to use just a ring like this by itself, because that toilet's going to compress quite low. Okay.
So if there's not a lot of room,
you don't want to use the horn, because what happens with those horns, if you have not a lot of room, is sometimes that wax will squeeze out and that horn will end up sitting directly on this, and it could cause a leak. So you only want to use those horns if you have maybe a tile floor or something where the toilet's sitting a little bit higher. But the horns are overall better because they help redirect the water. Okay. But these are fine for tight applications.
The horns do seem to, they constrict it. It's a smaller hole, yeah. But that's not a problem.
They help to redirect the water to help eliminate any future leaks. That's what they're about.
So a really important item to make the water flow right is the slope of the pipe. Generally in plumbing, the slope that's most standard is 1/4 inch per foot. So you can take the number of feet of run you have and basically divide it by 4, and that's how much slope you need. Now that's the minimum slope. So this level right here is a grade level.
On this right here, and more it climbs at an angle, the more of a pitch it shows you. I'm actually holding it backwards, but
So
That's how you know where your grade is.
And the lines
So if
correspond
it's-
to an eighth of an inch per foot, a quarter, 3/8, and a half.
Yep. So the countertop's flat, so that shows 0 grade. And if you were to slowly start picking this up, that would be an 1/8 inch, quarter inch, 3/8, half. That gives you an idea of the fall right there. So the reason this is important is you need to calculate your fall. So if you have 20 feet of pipe you need to install, you need to remember that you're going to be 5 inches deeper at the 20-foot mark than you are where you started. So you need to make sure you don't have footings in your way. You need to make sure that you don't have any other obstructions in your way. And if you're coming backwards into another device or a fixture, you want to make sure you have enough fall so you don't come out of the ground before you make it. So you need to make sure you have your starting point set at the proper depth to prevent that problem from happening.
Now, one of the problems when we put the plumbing in this basement is I calculated pretty much the exact slope that we needed, and it doesn't give you any wiggle room. So I had to continually take this and really feather it in just right because I didn't have any extra room. And a better idea is to
give yourself a couple extra inches to work with for sure.
So that makes it really easy to install because then you're not worried. You just throw it in and get it about right. Now the question is, can you go too much slope?
There's no such thing as too much slope. This is vertical. You can't go past vertical. So the reason for the minimum slope, there is too little slope. That's a big problem, but there's no such thing as too much slope.
So what happens in a system if you have too little slope, or even if you have valleys where it
So if you have too little slope or valleys, you'll actually create a belly, which all the hard solids will stop right there, and you'll get a backup. You'll start to have issues in your house, which is a very big problem. I fix those all the time, and they're very expensive. So you really want to make sure you have slope on every single piece of pipe you install, because that's a big issue that'll come back later after the home's been finished.
So I was able to do this because I had Chris helping me. Chris was actually living out of state at the time, so I would call him, I would text him, I would send him pictures. It's the principles are pretty simple, but I would say unless you're really experienced with plumbing, I wouldn't try it unless you had somebody to at least put eyes on it and look at it.
Agreed. You can cause some very expensive problems if you don't follow some basic rules and codes when this work's being done. And remember, if you make a mistake on something like this, you've got concrete covering it, flooring covering it, tile, tubs. There's all kind of fixtures in the house that could be on top of this. They all have to be removed to make a repair. So it's very important to do this right the first time. If it's done right, it'll last a lifetime.
But if you're confident and you have some help, I think it's a job that you can do. I have a couple extra tips for you. The first is when you're putting together your plumbing system, it's always good to dry fit without glue until you're sure that it's all right. But then make sure you glue it and don't bury something that's not glued together. The second one is using pea gravel or something like that doesn't compact a lot. Makes the process a lot easier. If you use sand, you got to compact it. So pea gravel is a really good material. The third thing is when you add concrete over your pea gravel, you don't have to smooth it out really well. You just want to make sure it's nice and flat. Screed it nice and flat and make sure it's not high. If it's high, then it'll make it hard to put self-leveling compound over it to put your finished floor onto. So the last element in this house is the sewer pump system that we had to put in for the basement apartment. And the reason we had to is the sewer actually goes out of the house about this high. And so we had to have a pump that pumps it up. We pumped it into the plumbing up top, and then it goes down with the rest of the sewage. And then it goes down here behind these shelves and out of the house, like I said, about this high. Okay, how these sewer pumps work is basically a large container. It looks like a big black garbage can that you put in the ground. And the sewage from the apartment flows into that. And then it has a float in there, and when it gets to a certain height of sewage, it pumps it all down. So you'll hear it come on and come off. Another element of it is, say you had a power outage or something. It actually has an alarm here. The purpose of the alarm is to let you know that the power's out or something, or the pump broke. Because if you didn't have that, if the pump broke down, and then you just keep flushing the toilet. You can imagine eventually it has a good seal on it here, so eventually hopefully it would back up in the house and you'd find it. But if the seal broke or something, the sewage would just all come out here until you saw it. So the alarm's really important. Okay, another plumbing detail on these is they have a 2-inch line that comes up that runs the sewage out. This is a stop, so if you ever have to replace the pump, you can turn that off so you don't get anything coming back down. And then also this is a 2-inch vent. Now the code on these 2-inch vents is they have to be a dedicated vent that goes all the way outside the house, and they can't hook into any other vent in the house. So it has to be, they want a 2-inch vent that's dedicated. So we talked a lot about vents, and this is actually where the vents come out outside of the house. Now there's 2 of them. The one we put in for all the bathroom and the kitchen we did, everything inside the house. The other one, you have to have a dedicated vent for the sewer pump system. It can't be hooked into this one, so they're 2 separate vents. One important thing on vents is they should drain. So even though they just have air in them, they need to drain, because imagine if some kid or something took a hose and filled this up with water and it didn't drain, then the vent would be full of water, it wouldn't work. So vents need to drain. Well, as you can see here, they have little screens in them that stop any wildlife, birds that get in there to keep those things out. So this here is just a sewer pump system. They also have what's called a sewer grinder system. Difference in price for the whole package to put this in is about $625. The sewer grinder's a little over twice that, $1,400. So the difference between these two is the pump is a little less robust. It can pump everything that's normal in there. Systems you wouldn't want to put like any baby wipes or anything tougher than just toilet paper. They will clog up if you do. Now the grinders, you would think that everyone would put one of those in. One thing, they are more money, and if they do plug up, I hear that it can ruin the grinder, so you're again in over $1,000 to fix it. And I talked to my local supplier, and they actually sell a lot more just pumps than the grinders. So as you can see, a plumbing project is complicated, but if you take your time and do it right, then it can be done. Again, it's something that you would want to have some experienced help on, or I wouldn't do it at all, but it can be done.